Hello, everyone. Thank you all for joining in. This session will be hosted by Hari Vasudevan. He's the software integration lead at PyEV 2022. Hari, you may begin with the answering the questions that were submitted via the form, and later we can look at the questions that come through the Zoom chat and YouTube web chat. Over to you.
Yeah, sure, Anita. So yeah, everyone, thanks for sending in the questions. I had gone through a few of them. I'm just looking at them now, and I'll read out some of them. If there are associated questions, you can ask me about that, and we can see how to take that forward. Okay, let's start with the first one. I think this is under team management for some reason, but I think this has been submitted by Ankit Chaudhary. So can you elaborate more in the AI report about what is the required data for unit tests? So Ankit, the thing about both, so maybe I'll digress a little bit, right? The thing about the software and algorithms bit for formula is that some of it might be like very specific to what you are trying to do, right? I can take an example, right? Like, so for some reason, if one of the teams is trying to do like slip control, right, as one of the algorithms on the vehicle, right, the data that you will be using to prove that will be different, right? So you will be using different data to do it. But more specific to the question, what is the required data for unit test, is that say you're taking something like the BMS, for example, right? And you say you have modeled it on a computer. The first stage of this testing would be that, say in the model, between the input and output, are you seeing behavior that you expect, right? And what are the deviations from that behavior and all? Have you simulated enough conditions on the actual battery pack? The simulated battery pack, for you to check what your input and output look like, right? Do they align to your understanding of how this thing should work? When you are actually doing the test on the hardware, again, this will be specific to that particular hardware. Say you're doing motor controller, for example, right? And you want to say you have a benchtop setup where you're first trying to get the motor to spin before you put it on the vehicle and so on. So during that time, what data do you log? What are the tests that you do? And what is the expected output, right? So the data should tell you the story of that this subsystem or this unit is working as expected. So that's sort of what we mean by what is the required data for unit tests. And this holds the same for, I think in the software section, there is also some more stuff about I think unit level tests, HIL, MIL. For all of that, remember that the data is context specific, but what the data should do is based on the inputs that you give to the system and based on the outputs that you get back, are you actually able to test for something? Are you able to verify that the system works as expected, right? So that's sort of the expectation here. I think we'll be following the same theme across multiple questions because there's a lot of similar questions that are coming up. But if anyone has any questions, you can stop me and ask, but otherwise I can just move on to the next question. Okay, you can ask the questions at the end also. Okay, so then the next question I see is in the automation testing tab in the software algorithm template. Could you elaborate on what is expected in system level testing details? So again, there are many phases of this, right? Say if you have a system level model and you're doing the model in loop testing, the idea would be that yes, you try to correlate what happens on the BMS, what happens on the motor controller, and you bring those together, and you again try to show the data that between what you simulated and the output that you got, and you're able to say that it makes sense, right? This is so an example might be that, say you have your BMS connected to your motor model. This is only in the model, right? Say you try to increase the torque, you see a certain acceleration in the motor, right? Now, what is the current that it should draw from the battery? When will you hit the overcurrent threshold for the battery, for example, right? That you should be able to tell from system level testing simulation, right? And on hardware, for example, what this would mean is, are you able to essentially replicate the same things, all the faults that you have set, all the thresholds that you have set? Are you able to justify all of that with data? I think in the on the firmware side, that is on the purely software, not just the algorithms bit, automation testing would also involve, like, are you able to test modules of your code separately, and what is the test vectors that you design so that you are able to sufficiently test a particular module of code. So anyway, that's automation testing and so on. So the next question is, how should we perform testing on modules which we do not have code available, like off the shelf BMS or motor controller? So it's a good question. I think that the first part of this is that if you don't have code available also in simulation, either in Python or MATLAB, you're still able to set up the rough characteristics of what the BMS should work like, right? So you should be able to set, like, voltage thresholds and then model the battery. Now, if you see that when you draw a certain amount of current, the battery voltage is dropping below cutoff, right? Then you should be able to match that with the performance of the real BMS. Now, if you have the actual BMS, in what this means is that we expect tests that are not just in the system, right? It's not that you get the motor controller, you get the BMS, you put them all together, and then you say that, yes, this is the low voltage threshold at which the motor is supposed to cut, the BMS is supposed to cut off power, right? Or close the contactors, open the contactors, sorry. What you would do is, you have the BMS on your bench top, and you're able to give it different voltages or different, like, simulated currents, and you're able to validate that the BMS actually cuts off, or the BMS actually has a particular behavior, right? Maybe your behavior is that if it draws this much current, the BMS should send some message to the motor controller that you should not allow more than this torque, right? Because that's what will determine whether your battery eventually goes to cut off or not. So you should be able to validate that on the bench or in simulation before you actually put it on the vehicle. Okay, let's see. I'm just trying to find the next few questions. Okay, there is a question by Kritika Gaute about what things are required for control data flow algorithm. Same person. What is the difference between high level block diagram? Okay, let's do this one. What are all the things required for control/data flow diagram, right? So there can be, like, two parts to this, right? If you are actually presenting a control loop, so one part of it would be, on the algorithm side, you would present what the control system or control loop is, right? The data flow diagram is a little different. So when you design code, within your code, data is passed from one function to another, and essentially the data flow diagram is about how this is handled within different modules of your code. Here I will step back a little bit to explain a little bit about how software that is written for an application is different from what we see in industry usually. So the sort of coding that you do for in college, for example, right, is mostly about functional programming. So you're trying to get to a certain outcome with the programming. You don't care about how it needs to be, how it is done, right? So think about it as you need to do something and you write everything in void main in C, right? Now that might achieve your purposes for university or for some applications, but when you move to code bases that have to be sustained over time, right? This strategy becomes very hard to scale over time, right? And you would have noticed some part of it between like handover from your seniors, for example, right, of the code required to run a vehicle, unless you're building a new vehicle, right? It's very difficult to understand that code. So the data flow diagram will also involve like how you actually break your code out, right? Are you actually are you following any oops sort of object oriented methods in your coding, right? How have you abstracted different layers in your code? Are the bottom level drivers separate from, say, Coulomb counting or any Kalman filter that you might have above that, right? And how does the data flow from the sensors through these various modules in the code to the application layer, right? So that is sort of what the data flow diagram indicates. So what is the difference? So the next question from the same person is, what is the difference in between the high level block diagram mentioned in the software interconnection and the data flow diagram in section 2 in the software related system? So I had gone through this earlier. So what we mean by high level block diagram is, say if you have like multiple processors on your board, for example, right? All of which have their own independent pieces of software running, right? The high level block diagrams sort of indicates the interconnection between these hardware realizations, processors, BMS, motor controller, something for the driver to interact with, the HMI, and how these are connected via buses, or how data is transferred between these. You might have UART somewhere, you might have CAN somewhere. So that is the high level block diagram. The data flow diagram is what I explained just now, which is essentially either within a component or across components, right? How does the data flow, right? So say if you have I'll go back to the similar example of BMS and motor controller. Say the BMS has to publish some data to the motor controller, right? So the BMS starts from like its measurements of current and voltage and so on, and you have certain functions that sort of that measure these and transmit this data up from the lowest level to the upper levels where your algorithm actually sits in the code, right? And then that algorithm or that function in your realization, maybe it's a function, that sends the code back through various layers of software onto, say, something that broadcasts over CAN, and then something on the motor controller that receives it, and it will again have its own chain of data flowing up and down, right? So that's what is expected in the data flow diagram in the software related section. So there is another question from Kritika, which is, what all details of system level testing is needed? So the more the details that you put, the better it is for you. And the more that this sort of tends towards actual data that you have from the vehicle, the better it is for you, right? I, like being part of Formula before, I know that there are times when you just have to put things together and get the system to work. But for this particular software integration aspect of PyEV, how much detail you can get into describing the testing that you do before you put it on a vehicle will make the case for that design to be better. How many times have you tested your BMS on a bench, right, with recorded data and the inputs and outputs? How many times have you done that for the motor controller? How many times have you done that for maybe the HMI or any of the data that is related from any of the HMI modules down to any of the other controllers, right? So that's essentially what it is. So it's not an absolute answer, This is essentially how much detail you can put in there compared to everybody else. Okay, so there is another question from Hollis. Can you please elaborate on what exactly should be added in the automation section? What kind of details are supposed to be added in the UML diagram? Okay, let's go to the what should be added in the automation section. So in the automation section, right, it again goes back to how you do your module level testing. Say you have an application that does Coulomb counting, or say you have an application that does Kalman filter for the battery SOC, right? How are you testing that module of code? So again, the answer is contextual. It is contextual to your design. How have you tested that? Um, so this I'm referring to section 2 in automation, on automation testing in the PyEV software template. How have you done this testing? Is it so? If you're testing just a module in code, then that means that it is software in loop, right? But if you do have hardware where you can simulate various inputs to the hardware to see how the hardware on the board, on your board, on the BMS board or any other board in your system works, that would be HIL testing, right? How much detail you can put into this determines how good your submission is. That is why it's sort of open. So I don't think we'll be able to define what exactly needs to go in there. You will need to put the details of all the modules that you have tested and system level tests that you have performed. Let's see, I lost the page where I had the questions. I think there is one question by Javjot Singh. What basic systems of which control algorithms are expected? For example, electric motor controller transmission. I'll take that one first. It depends on how much detail you have gone into the design of this, right? So say if you have taken an off-the-shelf motor controller and an off-the-shelf BMS and integrated them together, right? Then any control system that you design will necessarily be at the vehicle level, which means that you will be controlling the different states that these two subsystems are in, right? In which case it can be essentially like a state space system, right? A state transition system. So, and we would expect you to put the details of that. But in case you designed your own BMS board, right? Then you might have algorithms that control the charging and discharging of this. This could be as simple as, yes, we'll do constant current till this point, then we'll do constant voltage, right? And you're telling some charger to do that. How did you design that? How did you figure out when to switch from constant current to constant voltage, right? And if you have actually designed your motor controller, I don't think I've seen any team do that yet, but I would want to be surprised. Then how have you written the controllers for that, right? Like how have you designed your P and D, your D and Q control loops? And how did you realize them, right? Well, maybe the realization is not required, but how do you design them? How did you know what control gains to use? Say if you have, say, hypothetically, you have a cruise control feature on your vehicle, right? How is that cruise control implemented? Is it a proportional controller? It's a proportional integral controller. How do you draw that in a classical control loop diagram, right? So that is what is expected out of control algorithms. Right. One thing that I would want to say in this, last year when we had this question out, we had a lot of submissions for, say, the motor controller, saying that this is how the D loop works and the Q loop works, while the teams still used a off-the-shelf motor controller, right? Now that doesn't, I mean, that sort of a submission, I would discourage a submission like that, because I'm not sure that it adds to your design of the motor controller, because anyway you're using a motor controller that you have bought ready-made, right? then describing its control systems, you don't really know what's going on in there. So there's no point describing those control systems, right? You have to design the control, you have to describe the control systems that you have designed and implemented on the vehicle. There is a next question. Does filtering of the algorithm means testing against different scenarios? No, that was an example. I think we have mentioned, like, for example, design of control systems or design of filters. So by filtering, I might mean it could be that, say, your for some torque control algorithm, you need to filter the current before using it, right? Like, or for BMS algorithm to determine when to cut off, you can't use the current per se, but you have to use the filtered current, right? While performing that filtering, you might be using an FIR, IAR, or some other more complex filter, right? Or maybe it could be just a moving average. How did you design that filter? That's what that indicates. There is one more. While presenting, should display of data be displayed for each subsystem separately, or should display of data be displayed for each subsystem? Should there be a sequence of tests to this? I didn't quite get this. So if Jabjot, if you're here, would you mind clarifying your question on this? Or anyone from that team? Okay, I don't.
Sir, I
Yes.
meant that while presenting our control algorithms,
Mhm.
should there be a sequence of tests like we'll be following? Like first there would be inputs to the vehicle dynamic system, then it would go to the transmission, and then there would be inputs to the motor and motor controller, and then at the same time parallelly there would be inputs to the battery BMS. So, I mean, testing those subsystems and presenting them in a sequence like this, or should we present the data separately with inputs to the motor controller subsystem separately and the battery subsystem separately?
So if you see I think the sheet has space for both full system testing, and it has separately called out subsystem testing, right? So, I mean, ideally the way to do it would be first you do subsystem, present the data for that, and then you do system level testing. Now, see, honestly, like as judges, I like, if you have a lot of data in there, and if you do system level testing and present part of that data as subsystem testing, that could also be fine. But I'm quite sure that we'd be able to figure out from the way the data looks that, you have done full system testing, you're just taken a subsection of that data and you're showing that data as subsystem testing, right? Because subsystem testing here technically will be more exhaustive. You would test for many more cases in the subsystem, and then when you go to system level testing, you would test for fewer cases. So the example that you just said for system level testing, that you start from, like, throttle position, and you go from there to acceleration, battery current, battery torque, all of that, right? That would be system level testing, and you would present data for that. But specifically subsystem testing, you might have scenarios where you're testing whether your over voltage threshold actually leads to the battery pack sort of cutting itself off, right? So that would be subsystem testing separately.
Okay, got it.
So I would say that don't separate, like, keep the system testing on its own and do separate subsystem testing.
Okay, got it. Thank you.
So I think those are all the questions that are on the sheet. I'll just open it up to the people here. Are there any more questions you would want me to answer, or something that is confusing that you want to bring up?
Hari, there is a question in the chat box. If we purchase OEM BMS, then we have to sell our own Simulink model of battery?
I am actually trying to find the question. I don't see it in the chat box. Would you mind repeating that, Rita?
Yes, yes. If we purchase OEM BMS, then we have to sell our own Simulink model of battery.
If you okay, I'll answer it the way I interpret the question. So if you purchase your own BMS for the simulated results, yes, I mean it would add to your credit to have a cell model and build up a battery pack model. Um, I mean, I leave it to your judgment whether to use sim electronics or whether you want to write an RC model on your own. That would add to what you have to present. And if you can use that model to set thresholds on your purchased BMS, right? If you can make a correlation from the cell model to the BMS, to the actual BMS and the settings that you have on the BMS and how that cell model has helped you do that, that would add to the sort of the algorithm bit of your system and some of the model testing and so on. I think that's how I interpret that question. But if the person who's interpreted the question wants to clarify that, I can clarify it.
David, was your doubt clear?
Yes, sir, that's clear. That's enough. Thank you.
Cool.
Hari, we'll give it say another minute or so.
Sure.
Students or teams, if you have any questions, you can put it directly up in the chat box.
Do we need to put UML for different subsystems as well, or just the overall systems? I would defer to UMLs. I would say both, but I would defer towards the UML for the subsystems, especially the systems that contain their own running code. And UML essentially shows you how data transfer happens between modules of code, not necessarily modules of hardware, though it can encompass modules of hardware. So I would say for different subsystems is more important than showing the overall system, but do show the overall system. That also helps.
Thanks, Hari. Looks like we can end the session now. I'll just have a look at the YouTube chat if there are any queries.
Sure.
Okay, I think we are good to go. Okay.
All right.
Thanks a lot, Hari. Thank you for making the time. It is a pleasure to have this session with you.
Yeah, same here. I'm looking forward to seeing all the vehicles on the track actually, and all the best to everyone building away.
Thanks, Hari. Thanks to all the teams for joining in. In case if you still have any doubts or questions, please feel free to write to us. Thank you once again, and have a good day ahead.